this video we are going to cover several aspects of the lifecycle management of servers and services in the Nearby One solution. The Nearby One solution is composed of two main components, the Nearby Orchestration Platform, which is the main central component, and the Nearby Blocks, which are able to manage different deployment technologies. Nearby One is able to manage services spawning from the data center to the far edge, including micro data centers that could be located at the near edge. Let's discuss first how it can be used to provide managed services to third parties and customers. Let's suppose first that the telco operator wants to provide private LTE services to two customers. First thing would be to design the solution in day -2. Day -1 would be committed to pre-registration of the infrastructures for the customers. Day 0 would be the time at which the nodes are onboarded, provisioned, and prepared for deploying services. After that, the telco would deploy the network components in the infrastructure or at the edge for the two tenants. Then, each one of the tenants would be able to log in using its credentials and be able to deploy applications from the catalog of applications. Another tenant may repeat the same process in a different moment in time with different applications but sharing some of the infrastructure. Finally, the telco operator would be managing, accounting, and updating the components for the customers. Let's look now at the different steps that would be followed for this process. The orchestration platform, inventory, call home service for zero-touch provisioning, and the BNF and app catalog would be the main components in use. When a new setup is prepared for a customer and new nodes need to be onboarded, first thing is they need to be registered using the dashboard or an API. Using the dashboard, the telco operator would be able to provide a name, MAC address, or TPM key for identification of the node after registration. It is also possible to provide a number of tags associated to the device for further search capabilities in the platform. One of those tags is special. It's the NZTP tag. It tells the system that this node will be automatically onboarded, and the telco would be able to decide what flavor of operating system would be used for provisioning. At this point, the node is ready to be onboarded. It shows in the map, but is not yet provisioned. The next step would be to provide over-the-top IP connectivity and power to the node. The nodes can be provided by the OEM with a pre-installed ROM image that can be used for booting the machine. That image contains all needed components to bootstrap the machine, performing the call home to the cloud service, obtain the right hardware configuration parameters, image of the operating system, and agents from the Nearby One solution. This process is completely transparent. When the node is bootstrapped for the first time, it will perform the call home using secure channels. It's going to do an initial hardware discovery to populate the catalog of servers in the system. With that inventory information, the orchestrator is going to be able later on to make decisions on placement of services. And when that finishes, the system gets provisioned with the operating system and finally started and get ready for operation of customer services. The whole process can take a couple of minutes depending on the speed of the network. Finally, the node is up and ready to be used for services. Once the node is ready, it immediately starts publishing data about the platform telemetry, chassis telemetry, and the network telemetry. At any moment, the information regarding the platform and the chassis of the node is available through the telemetry dashboard. At the same time, the node is actively monitoring the observed latencies, bandwidth, and jitters with all the other nodes of the customer facilities. This information can be used later on to decide where to place services based on latencies. At this point, the next step is to start deploying services in the hardware. Services may comprise BNFs and IT applications and can be packaged using VMs, cloud-native containers, or hybrid solutions. For each active service, application KPIs are continuously collected. So let's start with the deployment of the network services provided by the telco. Using an administrator login credentials, the telco can get into the system, get access to the catalog of BNFs and applications, deploy several virtual networks that could be used for the deployment of the network services, configure different components, like in this case the Open RAN component and a lightweight open source core, make sure that all parameters are populated and that the right components are connected properly, select the small cells that want to be managed. In this case, only one was available. Notice that the data has been filtered out based on the tags that we provided before. And we are good to go when all blocks in the system show green status. If we plan to share a network with other tenants, in this case our customers, we can mark this network as an external shared network, provide a name that can be used by the other tenants to attach their services to this network, and continue. Each service needs to get a name associated for deployment. And now it's time to decide where to deploy the service. The service placement location can be decided by the system or by the user. In this case, we show how, taking as an anchor point a small cell in the system, we can later on decide which server to pick based on distance, in which case the system will only let us select nodes within a certain range from the anchor point, or latencies. So the system that is continuously monitoring the latencies between all the components in the network may pick nodes that fall within a range of maximum latency from the small cell. Finally, it's time to deploy. The services view allows us to check the status of the high-level services and all the components required for the deployment. As it can be observed, the telemetry of the node shows that some activity is happening. Some minutes later, all images have been sent to the nodes, instantiated, and continuously monitored. As it can be observed in this cloud-native solution, several containers were deployed. At this point, we need to deploy the tenant applications when the network connectivity has already been provided by the telco. Let's assume two tenants in parallel log into the dashboard using different credentials. Each one of them will have visibility to their services, and no one of them will see the network services that have been provided by the telco. They will be able to create new virtual networks or to attach to the networks that had been created and shared by the telco before. In this case, one of them is deploying a XCDN service connected to the EPC that was deployed for the private LTE services, while the other tenant is deploying a video analytics service that will be connected to an LTE IP camera. Each tenant selects what node to use to deploy its services. In this case, both of them would be sharing a single box solution. That is the box where the telco previously deployed the Open RAN plus the EPC. Some minutes later, both services are up and running in this container-based solution. At this point, the environment is ready and the nearby solution keeps monitoring the deployments. With the information that is provided by the platform chassis network and the KPIs of the application, the orchestration platform has all the information needed to actively manage the services.